A single thunderhead cloud can unleash more energy than an atomic bomb, dramatically shaping landscapes and lives below. These towering atmospheric giants are not just rainmakers, they are colossal engines of pure weather chaos. Imagine an entire mountain range of water vapor and ice ascending miles into the sky in mere minutes. This incredible vertical development creates Earth's most violent and visually stunning meteorological events. What exactly drives these immense and often terrifying atmospheric structures to such destructive power? Known scientifically as cumulonimbus clouds, they represent the pinnacle of atmospheric instability and energy release. Understanding their formation is crucial for predicting severe weather, protecting communities, and ensuring safety. These powerful clouds begin forming when warm, moist air near the surface becomes significantly unstable. This instability causes air parcels to rapidly ascend through the atmosphere, defying gravity with surprising force. Think of it as a massive, invisible elevator carrying vast quantities of heat and moisture upwards continuously. As this air rises, it cools, and its water vapor condenses, forming visible cloud droplets and releasing latent heat. This released heat warms the surrounding air within the cloud, making it even more buoyant and accelerating its ascent. This self-sustaining process generates the distinctive towering shape of a developing cumulonimbus cloud. They stretch from the lowest atmospheric layers, often just hundreds of feet above ground, to heights of many miles. Some thunderheads can penetrate the stratosphere, reaching altitudes where commercial jetliners typically cruise. These enormous clouds are essentially nature's most efficient machines for transferring energy vertically across the atmosphere. The formation process starts with warm, humid air accumulating close to the Earth's surface on specific days. A trigger, like a frontal boundary or localized heating, forces this buoyant air to begin its upward journey. As the air rises, it expands and cools, eventually reaching its dew point temperature, causing condensation. This condensation creates vast numbers of tiny cloud droplets, forming the initial puffy cumulus cloud stage.
Crucially, as water vapor condenses into liquid, it releases latent heat, which fuels the cloud's further growth. This additional heat makes the air within the cloud warmer than its surroundings, intensifying the powerful updraft.
Imagine an invisible chimney, drawing in more warm, moist air from below and powering it skyward relentlessly.
These updrafts can reach incredible speeds, sometimes exceeding 100 miles per hour, carrying everything with them.
As the cloud grows taller, temperatures within its upper regions drop far below freezing, even when the air is still warm. Here, supercooled water droplets coexist with ice crystals, creating a highly volatile mix for future weather. But that's not the strangest part about what happens inside these atmospheric factories of severe weather. Collisions between these supercooled droplets and ice crystals are vital for generating electrical charges. Heavier ice particles carrying negative charges fall downwards, while lighter, positively charged ice ascends. This separation of charges within the cloud creates an immense electrical potential, leading to spectacular lightning. The incredible energy release from a single lightning strike can instantaneously heat the air to extreme temperatures. This rapid heating causes the air to violently expand, generating the powerful sound waves we recognize as thunder. Wait until you hear what comes next regarding the formation of even more dangerous weather phenomena. The powerful updrafts continue to lift water droplets and ice crystals higher into the frigid upper atmosphere. These particles grow larger through accretion, gathering more supercooled water as they hurtle upwards and downwards. If the updraft is strong enough, these growing ice pellets can be repeatedly lifted and fall, forming layers of ice. This process creates hail, sometimes growing to the size of golf balls or even larger before falling to Earth. The upper part of the cumulonimbus cloud often spreads out, forming an anvil shape as it hits the tropopause. This anvil top signifies the cloud has reached its maximum vertical extent, pushing against the stable stratosphere. Simultaneously, strong downdrafts develop as precipitation falls, pulling cold air rapidly towards the surface. These downdrafts can create powerful microbursts, localized columns of sinking air that spread out violently. These microbursts produce damaging straight-line winds, sometimes exceeding hurricane force at ground level.
And then something unexpected happened as the rotating updrafts became even more focused and intense.
In certain conditions, a rotating updraft, called a mesocyclone, can form within the heart of the thunderhead. This rotating column of air is the precursor for the most destructive of all atmospheric phenomena, the tornado. Tornadoes are violently rotating columns of air, extending from a cumulonimbus cloud to the ground below. The sheer destructive force unleashed by a mature cumulonimbus cloud profoundly impacts everything it encounters. Severe thunderstorms generated by these clouds bring torrential rains, often leading to dangerous flash floods. Hailstones can devastate crops, damage vehicles, and even pose a significant threat to lives and property. Powerful straight-line winds from downdrafts flatten trees, destroy buildings, and cause widespread power outages. Lightning strikes ignite countless wildfires annually and represent a leading cause of weather-related fatalities. However, the most fearsome impact of these clouds is undeniably the formation of incredibly destructive tornadoes. Tornadoes can level entire towns in minutes, leaving trails of unimaginable destruction and human suffering. Predicting the exact path and intensity of these severe weather events remains a significant scientific challenge. Meteorologists worldwide constantly monitor atmospheric conditions to provide timely warnings for affected areas. Advanced radar systems track precipitation, wind shear, and rotation within these menacing cloud structures. This vital information allows communities to prepare, evacuate, and minimize the loss of life and property. Understanding cumulonimbus dynamics is crucial for aviation, as turbulence and icing pose serious threats to aircraft. Pilots must navigate around these towering storms, often rerouting flights to ensure passenger safety and comfort. The energy budget of the Earth is significantly influenced by these clouds, redistributing heat and moisture globally. They are powerful reminders of the atmosphere's dynamic nature and the immense forces constantly at play above us. Clouds are truly nature's observing these most formidable natural powerful and phenomena offers both complex a humbling weather perspective and an engine's deep scientific fascination.
Cumulonimbus clouds are truly nature's most powerful and complex weather engines, driving everything from rain to tornadoes.
Their intricate formation, immense energy, and profound impacts reveal the mesmerizing science behind our planet's weather. These atmospheric marvels continue to challenge scientists, pushing the boundaries of meteorological understanding and forecasting. Every thunderhead you see is a testament to the incredible, unseen power continuously at work in Earth's skies. Remember, the atmosphere is a dynamic, living system, constantly evolving and surprising us with its raw power. If you found this journey into the heart of a thunderhead fascinating, subscribe for more incredible scientific explorations. Share your thoughts in the comments below about which weather phenomenon you find most awe-inspiring. Hit the like button to help us share the wonders of atmospheric science with even more curious minds.